Good morning. Good morning, students. So, good morning. Fine. So, we are at the end of the periodic table, classification of periodic table. And as I told, today I am going to summarize what and all we have discussed for 5 to 10 minutes. Then we will start solving some of the competitive exam questions. Okay? Fine. So whether still students they have to come or we will start with the class. Already it is time is done. So I will be starting with the class. Okay. Now when it comes to periodic classification of elements, history, right? That's where we have discussed about the Beriner, right? Who proposed law of triads. Okay, so who proposed law of triads, that is one thing. Then when it comes to Newland's theory, what is that? Theory of octaves, right? So theory of octaves. So now these are the two major contributions before coming of the Mendeleev's contribution. Then comes the Mendeleev's, right? So Mendeleev's periodic table, who prepared arrangement of the element based on the atomic weight. So up to Mendeleev's it was based on the atomic weight. There is no question of atomic number. Everything was based on atomic weight, right? So yes, atomic mass. That's where we have the Mendeleev's periodic table. So what was the drawback? Drawback here was, with respect to Mendeleev's table, it was first thing based on atomic mass or atomic weight. So that's where we have the major drawback. Then there was not much place which has been given for the new elements which will be discovered, right? And there were many gaps in between the elements. So that is another thing. So last one is, he didn't discuss anything about the isotopes, right? So that's where we have the Mendeleev's periodic table, its contribution and its demerits. All of you have understood? Now comes the modern periodic table, and Mendeleev will be considered as father of classification of elements or father of periodic table. So now Mendeleev's periodic law, it tells that property of the elements, periodicity in the property of the elements will be based on the atomic weight. But when it comes to modern periodic law, which talks about atomic number, So on what basis? It was based on Mosley's experiment, where he plotted the graph frequency of X-ray radiation or X-rays, and with respect to atomic number he got the straight line, but with respect to atomic mass he didn't got the straight line. So based on that, people came to know that yes, atomic number is the one which is going to decide the property of the element. Fine. So that's where we have the history of the classification of elements. Then we have discussed about periodic table. Now in case of the periodic table, first one is features of the periodic table. Definitely first sentence should be, it is based on the atomic number. Modern periodic table is based on the atomic number, right? Then next point, there are periods which will be of 7 in number, and there are groups which are 18 in number. So that's where we have the periods and groups. So how many periods are there? 7 periods are there. So how many groups are there? 18 groups are there, right? So that's where we have the periodic table, modern periodic table. And groups are also called as families. Groups are also called as families. That is because those elements which belongs to a particular group will have the similar properties which is due to similar outer electronic configuration, right? So when it comes to periods, each period, when you are moving from period 1 to period 2, that means we are moving to the next energy level, right? So that's what with related to periods groups. Now, modern periodic table has been classified as S, P, D and F block elements. They have been classified as S, P, D and F block elements, right? Now, when it comes to S block, it is group 1 and group 2 which belongs to S block. Now when it comes to P block, it is group 13 to group 18 which belongs to P block. So what about D block? D block is from group number 3 to group number 12. So it starts from group number 3 to group number 12. That's where we have the D block. And what about F block? They are located between group 3 and 4, right? So that's where we have lanthanoid series. That's where we have lanthanoid series and actinoid series, right? So that's where we have the element. Now when it comes to period, so it belongs to, these elements belongs to period number 6 and 7. They belongs to period number 6 and 7 and their location is between group 3 and 4, right? That's where we have the different category of element. Our elements can be categorized into different forms based on which particular subshell in the outermost shell is getting filled up, right? And it's not compulsory that outermost shell. In case of the D, it is the penultimate D subshell is going to get filled up. But when it comes to F, it is inner shell to compare to penultimate shell. Inner shell is getting filled up. Therefore, D is called as a transition element. Why they are called as transition element? That is because D block elements, they are located between S and P block, metal and non-metal. So therefore, they are called as transition elements, right? But when it comes to F block, they are called as inner transition elements. And when it comes to actinoid series, they are radioactive in nature, right? And when it comes to S and P, they are called as representative elements. They can be called as representative elements. That is because of their reactiveness. That is one thing. And when it comes to P block, we have metals, non-metals and metalloids, which is not found in any of the other blocks of the periodic table, right? So which element is dominating? Naturally, metals are dominating in the periodic table. Fine? All of you have understood? So that's where we have the elements. Now, next thing here is with respect to different properties, how they have been distributed across the periodic table with respect to the properties. Say for example, I have metals and non-metals. Anyway, metalloids we are not going to much give importance because elements are very less and they will be having intermediate property between metals and non-metals, or I can tell they have both the properties. Some of the properties they will show related to metals and some of the properties they will show related to non-metals. So that's where I have metals and non-metals as a major category. Now, metals are electropositive in nature, right? Metals are electropositive in nature and non-metals are electronegative in nature. Don't use the short form as I have written. Okay, so try to write in complete this one only. So electropositive and electronegative, that is the major difference between metals and non-metals, right? Naturally, since electropositive, they can attain or they can become easily cations due to the electropositive character, and they can easily become anions due to the electronegative character, right? Now, when it comes to the metals, normally they will be of larger sized atom. They will be of larger sized atom. Here it will be of smaller size. It will be of smaller size. Right? And in the periodic table, metals are present on the left side and non-metals are present on the right side. Right? Non-metals are, as usual, we have seen in non-metals which are present abundantly in the P block. And P block is present on the right side. And group 1 and 2, especially alkali and alkaline earth metals, they comes under the left side. Therefore, metals are on the left side and non-metals are on the right side. That doesn't mean that metals are restricted to left side. No. Major one it is on the left side, but still in the center of the periodic table also we have the metals like transition metals. All of you have understood? So that's where we have the metals and non-metals. Now, question can be for 2 to 3 marks. Questions can be explain the distribution of metals and non-metals across the periodic table, or explain the electronegative character across the periodic table, or electropositive character. Like that, questions will be there. Now, before that, as we have discussed, we have to define. So, electropositive means it is the ability of the element to donate the electron, or which is having less affinity towards the electron. They are called as electropositive. Electronegative means these are the elements which will be having affinity towards the electron, or you can tell shared electron. That means we are dealing with the covalent linked molecules or elements. Okay, na? So that's where we have the electronegative, electropositive, electronegative. Electropositive, less attraction or low affinity. Electronegative means high affinity towards the electron, or high attraction towards the electron. That's where we have the electropositive and electronegative. Now, when it comes to atomic size, if you understand this one, everything you are going to understand. When it comes to atomic size, all of us we know, when it comes to atomic size, it is going to increase. I will write it as AS. Don't use the short form in the exam. Once again I am telling. It will be decreasing along the period. So I will consider this one as period. And I will consider this one as groups which are moving downward. So atomic size is going to decrease across the period from left to right. And atomic size is going to increase from top to bottom, down the group. Fine. So that is related to atomic size. Okay. Now here we have discussed even about the ionic radius. We have discussed. You can put this diagram in your notes so that you can just glance it while going for the exams. Okay. Na? So ionic radius, as I have told, anionic radius or anions will be of larger size and cations will be of smaller size, right? So that's what we have discussed. Now, along the period or across the period, why atomic size should decrease? That is because electrons are added to the same energy level. But at the same time, there is increase in the atomic number. Down the group, why there should be increasing in the atomic size? That is because when we are moving down the group, we are moving to the next energy level. So therefore, although there is increasing in the atomic number, but still atomic size will be increasing. That is because we are moving to the next energy level that is related to atomic size. Right? Now, we will talk about electronegativity. We will talk about electronegativity. Once again, I am telling, don't use the short form. Okay? So, electronegativity. So, what do you mean by electronegativity? That is, it is the ability of an element to attract the electron in a covalent bond or shared electron towards itself. So, that's where we have the electronegativity. Now, if I plot the diagram, so that's where I have the period and that's where I have the groups. Right? So now, along the period from left to right, what is happening to electronegativity? En, we will imagine En is electronegativity, but don't use the same thing in your exam. So what is happening to electronegativity? It's going to increase when you are moving from left to right. Now when you are moving down the group, what is happening to electronegativity? It is getting decreased. It is getting decreased, right? So that's where we have the electronegativity. Now if I talk about electropositivity, okay? Now I can tell that if I put the diagram across the period, what will happen? Can anyone? Across the period, what will happen? Electropositivity. What will happen to electropositivity when you are moving left to rightward direction in the periodic table? What will happen to electropositivity? Can anyone? It will increase or it will decrease? Yes, very good. It's going to decrease. EP, I will make it. It's going to decrease. Down the group, what will happen? Down the group, it's going to increase. Very good. Down the group, electropositivity is going to increase. Exactly opposite to that of the electronegativity. That's what we can see. Right? Now, based on that, I will consider 3 points here. So, based on that, I can tell that atomic size or atomic radius, whatever it is, atomic size or atomic radius is directly proportional to electropositivity, because as there is a decrease in the atomic size, even electropositivity is getting decreased. So directly proportional to electropositivity and inversely proportional to electronegativity. All of you will agree? Fine. So that can be the relation. Atomic size will be directly proportional to electropositivity and inversely proportional to electronegativity. So due to that, we can tell that electropositivity is inversely proportional to electronegativity. Electropositivity is inversely proportional to electronegativity. That's what we can conclude. Right? Now, if you go back, metals and non-metals, we have discussed, right? Features of metals and non-metals. Metals are electropositive, non-metals are electronegative. So in that case, if I talk about metal and non-metallic character, metal and non-metallic character, if I plot the graph, how it will be done? Across the period, non-metallic character should increase. Non-metallic character should increase because electronegativity is getting increased. But at the same time, metallic character is going to decrease. Now down the group, what will happen? Down the group, non-metallic character is going to decrease and metallic character is going to increase due to the increasing in the atomic size. Metals, they are larger in size. That's what I told, right? That's what we can have the conclusion. Or to be more appropriate, I can tell that if you imagine this one as a periodic table, like this, metallic character is going to increase. Like this, like metallic character is going to increase. And like this, non-metallic character is going to increase. Non-metallic character is going to increase, whatever it is. All of you will agree? Fine. So if that is the case, I can put the relation that metallic character is directly proportional to electropositivity and inversely proportional to electronegativity. Fine, all of you will agree? Same thing, reverse for the non-metallic character. Same thing in reverse for the non-metallic character, where it is directly proportional to electronegativity and inversely proportional to electropositivity. Fine, all of you have understood? Okay. So please remember, in all the groups, as you move down, the last element in those groups will be having metallic character. But those metals like alkali and alkaline earth metals are called as class A type of metals, and whichever comes on the other side, they will be considered as class B. Okay. So anyway, you can remember that in all the groups, last element will be metallic in nature. All of you have understood? So this is what we can have the conclusion based on the picture. Fine. So we'll move to the next one. So electronegativity is done, electropositivity is done, and the relation we have derived the relation based on the picture. Atomic size, I will keep it there only. I am not going to disturb the atomic size because that is the one which is the deciding factor for these properties. Okay, na? Atomic size is the one which is going to have the impact on these properties. Therefore, I have kept atomic size as it is. Okay? Now, I will come to ionization enthalpy. I will come to ionization enthalpy. Right? So, which can be represented as delta IH. Now, when it comes to ionization enthalpy, what do you mean by ionization enthalpy? It is the amount of energy required to remove the outer electron in the gaseous state of the atom. Right? So, that is nothing but ionization enthalpy. That means, in the sentence itself it is there. Amount of energy required. That means we are using the energy. So naturally enthalpy word we are using. So therefore it should be thermodynamic way. We have to give the values. So in that way values will be of positive value because there is a utilization of energy. There is an investment of energy. Therefore whatever value is there, it will be of positive value with having unit of kilojoules per mole. Anything is fine. Unit will be kilojoules per mole. Right? Now in that case, if I want to see distribution of elements with respect to ionization enthalpy, now across the period, what should happen? It should increase or it should decrease. Ionization enthalpy, whether it should increase or it should decrease across the period. First we will go with period. Across the period, what will happen to the ionization enthalpy? Ionization increase across the period. Yes, all of you are right. It's going to increase. Naturally, down the group it's going to decrease. Naturally, down the group it's going to decrease. Therefore, I can conclude that. Remember, therefore I can conclude that metals have low ionization enthalpy. All of you will agree? Metals have low ionization enthalpy. That means it is easy to remove the electron from the metals. That is because of its large size. All of you will agree? So therefore we can tell that metals have low ionization enthalpy. So that means it is easy to remove the electron from the metals. So due to that they are electropositive. See how we can correlate. So due to that metals are electropositive in nature because they have the low ionization enthalpy. Alkali metals, they have the very low ionization enthalpy but positive value only because there should be utilization of energy because we are taking negative charge away from the positive charge. So there should be investment of energy, no doubt. And inert gas in each period will be having highest ionization enthalpy. Fine? So all of you have understood? So in that case non-metals have high ionization enthalpy. Therefore, they are poor donors of electron. They can accept. So that's what we can conclude. Okay? Now, last one is electron gain enthalpy. Last one is electron gain enthalpy. Right? So what is the unit? Unit is EGH. That is the unit for electron gain enthalpy. How to define? If you want to define the electron gain enthalpy, we can tell that it is the amount of energy required. It is amount of energy released when an electron is added to an atom. It is the amount of energy released when an electron is added to the atom. When atoms are in its gaseous state and ground state. Fine? So that's where we have the electron gain enthalpy. Our gaseous state, why we have to mention that one? Especially when it comes to ionization and electron gain enthalpy. That gaseous state we have to mention. What is the reason? The reason is, as I told yesterday, in gaseous state interatomic interaction will be nil or negligible. So neighboring atom is not going to have any effect on the atom in which we are interested. Therefore, we have to go with the gaseous state. Fine? So that's why we have the electron gain enthalpy. Now if I want to plot the picture, period, and this is down the group, what will happen to the electron gain enthalpy? Electron affinity increases across the period and decreases down the group. Very good. So naturally, electron gain enthalpy is going to increase. More amount of energy is going to release. But please remember, if you go with exactly mathematics value, then it will be of very, very low value because negative sign is there, right? So electron gain enthalpy except inert gas, all the element it will show the negative value. But ionization enthalpy, everywhere it is positive value. Okay? So that's why electron gain enthalpy is going to increase across the period and it's going to decrease down the group. So therefore, same way I can tell that metals have low ionization enthalpy, right? So here low electron gain enthalpy. Low electron gain enthalpy. That means less negative value. Don't go exactly with values. If you go with exactly with values, it will be having high electron gain enthalpy value because negative value is less. So don't get confused. Okay na? And non-metals have high electron gain enthalpy. All of you have understood? Any doubts? Okay na? So low electron gain enthalpy means it is having lower negative value. High electron gain enthalpy means it is having higher negative value. That means in this case more energy will be released and in this case less energy will be released. Fine? So that's where we have the relation between metals and non-metals with respect to electron gain enthalpy and ionization enthalpy. Now, with respect to atomic size, if I want to correlate with atomic size, what is happening to ionization enthalpy, whether it is directly related or inversely related? Atomic size and ionization enthalpy, whether they are directly related or inversely related. Sorry. Tell me, whether it is directly related or inversely related. Darshan. So according to Darshan, ionization enthalpy is directly related to atomic size. All of you agree with that? No. How it can be directly related? Atomic size is getting decreased, but ionization enthalpy is increasing. It is inversely related. Please remember, as the atomic size is large, ionization enthalpy will be low. So they are not directly related, inversely related. Correction. Okay na? So ionization enthalpy should come here. Ionization enthalpy should come here. What about electron gain enthalpy? What about electron gain enthalpy? Ionization enthalpy, yes, atomic size is less, more ionization enthalpy. What about electron gain enthalpy? So here also same thing. They are in the same category. Electron gain enthalpy, right? So they are in the same category because as the atomic size decreases, more energy will be released. As the atomic size decreases, more energy will be released. So therefore, both are inversely related. But please remember, once again I am repeating, electron gain enthalpy will be increased in the sense negative value will get increased. I am not talking about the values. If you go with mathematics, as the negative value increases, that shows that the value of that integer is getting decreased. That is different story. Don't go exactly with mathematics. Okay na? So what I mean to tell you is, as there is a decrease in the atomic size, electron gain enthalpy is also getting increased in the sense more energy will be released. Not related to values. Please remember. Okay? So therefore both of them, they are inversely related to atomic size. All of you will agree? And even electron gain enthalpy unit is also same, kilojoules per mole. Okay? Any doubts? But there are some exceptional cases for these properties. Right? That's what we have discussed, nitrogen, oxygen. Right? Ionization enthalpy should have been less for nitrogen compared to oxygen. But that is not happening. There are small variations here and there. That is will be due to the electronic configuration or might be due to the in which subshell electrons are present. Even those will be having a bit effect on the properties. All of you have understood? So that's what we have discussed. Then we have discussed about diagonal relation. Then we have discussed about the diagonal relation. So overall, if I want to tell atomic size, now you should tell me which and all will come into the numerator and which and all will come into the denominator. Can anyone tell me? So I will write metals. Which and all you should write? I will tell that one here. Non-metals. Metals we will represent it as M. Non-metals as Nm. Then we will be writing about electronegativity. Electronegativity. I will write that one as En. Electro positivity. I will write it as Ep. Then ionization enthalpy and electron gain enthalpy. So we will go with delta IH, delta EGH. Don't use the short form in the exam. This is acceptable, but not this one. Okay, another important point here is in some textbooks, in your NCERT, they have given with enthalpy. But in some textbook, I think Deepa publishers and all, they might have discussed it related to electron affinity. Instead of electron gain enthalpy, they will be talking about electron affinity. So don't get confused. Electron affinity, it will be shown as a positive value. They are not talking about enthalpy, they are talking about electron affinity. So as the electron affinity is more values, positive values. As electron gain enthalpy is more negative values. So don't get confused. In some of the textbook they have given as electron affinity. So electron gain enthalpy, whatever negative value is there, large negative values, same thing will be with large positive values in electron affinity. So don't get confused. In some of the textbook they have discussed like that. But in your NCERT, it is electron gain enthalpy. So we will go with electron gain enthalpy only. Fine. So now can you tell me among these which will come in the term, which will come in the numerator? First we will go with numerator. Tell me which and all should come to the numerator. First. Oh, which and all will come into the numerator? Non-metals and electronegativity. Gahan is telling. I am talking about numerator, not denominator. So electropositivity, it will come into the numerator. Electron, okay, non-metallic character. Okay, electropositive. Okay, metal and electropositivity. Yes, metal and electropositivity, they will come into the numerator, no doubt. Right? Then anything else which will come in the numerator? So that is metallic character and electropositivity, they will come in the numerator. Fine. So what will come in the denominator? What will come in the denominator? Yes, metals and non-metals. Okay, fine. So non-metals will come in the denominator. Then what else? Next is ionization enthalpy. Next is electron gain enthalpy. So all this comes in the denominator. All of you will agree? So we have total 6 characters. There only we have written 5. What else is left over? So left over is electronegativity. Electronegativity, where it comes? Electronegativity, denominator or numerator? Naturally it should come in the denominator. Right? So this is what the relation of these characters with related to atomic size. These are the relation between these characters with respect to atomic size. Fine? Okay? So if you remember this final equation, then it is done. You can explain anything in the periodic table. Okay? Fine. So this is overall picture. Now we will start discussing some of the questions from the competitive exams. We will start discussing. So what I will do is, I will be dictating the questions. You can write it down, and even I will write it on the board. Then you have to give me the answer. Okay? First one, which was asked in All India Medical examination. Earlier it was there, AIIMS. Okay, na? So now, that's where we have the first question is, which of the following? Which of the following? You can write it down. You can make one. You can maintain one notebook for this. Which of the following sequence contains? Which of the following sequence contains atomic number? Atomic number. Which of the following sequence contains atomic number of only representative elements? Contains only of representative elements. Please remember, I have included CET, NEET, and even related questions and even JE questions. Okay. So all of the questions I have included in this questions. Some of the questions I have included. Along with that, related questions also, other competitive exam questions also I have included. Now for this option A, 55, 12, 48, 53. Option B, 13, 33, 54, 80. Then option C, 3, 33, 53, 87. And option D, 22, 23, 33, then 55, then 66. So that's where we have the numbers. So option A is 55, 12, 48 and 53. Option B is 13, 33, 54, 80. Then option C, 3, 33, 53, 87. Option D, 22, 33, 55, 66. Tell me. And they are asking about representative elements. Representative elements means what are those representative elements which belongs to S and P block. This information you should know first. S and P block you should know. Okay now? So then in between we have the transition elements. So transition elements will be from 21 to 30. Then 39 to 48 because we have to add. Okay. So then 57 to 80. Then 89 to 112. Okay, all of them we have the transition elements, in between elements. So which should be the one? Which are those options which does not have any number from this? They should be the answer. ಇವಿಷ್ಟು ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಯಾವುದರಲ್ಲಿ ಈ ನಂಬರ್ಗಳಿಲ್ವೋ, ಇಲ್ಲಿ ಬರೋ ನಂಬರ್ಗಳಿಲ್ವೋ, ದೇ ಶುಡ್ ಬಿ ದಿ ಆನ್ಸರ್. ಸಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 55, right? So 12, 48, 53 is there, 48 is here. So option A is not there. So 33, 13, 33, 54, 80. So right, 80 is here. Option B is also gone. Then comes option C. Someone has written option C. Oh, many of you. Yes, option C should be the answer because these numbers are not there here. Right? So therefore it should be option C. B, it is there, 66. Somewhere it will come in between 57 to 80. So therefore option C should be the answer. Right? First thing, to answer this question you should know what you mean by representative elements. Okay, then only you can answer this particular question. So representative elements can be either S block and P block elements are considered as representative elements. So in that case, why they are called as representative elements? Because of their reactivity. Okay, because of their reactivity. So first question, option C is the answer. So shall we move to the next one? Any doubt in this? Any doubts? All of you have understood, right? So shall we move to the next one? Next question is, it's related to CET question, Karnataka CET only. An element with atomic number 21 is a, with atomic number 21 is a, option is transition element. Option B, alkali metal. Option C, halogen. Option D, representative element. Representative element. So these are the options. Can anyone? These are the options. Okay, very good. Option A, people are writing option A is transition element. Okay, so first what we have to do? We have to write the electronic configuration, right? So for this type of question, first you should write the electronic configuration. So since it is 21, we can go with the argon, right? So we can go with the argon. So leftover is 3 electron. So therefore it should be 4s2 3d1. Yes, 4s2 3d1. Okay now. So that's where we have the electronic configuration. Now this option is getting filled up, therefore it should be transition element. Straight away we can give the answer also, no need to calculate, because halogen, representative element, alkali metals, they are of similar options, because representative elements also includes halogen, it also includes alkali also. Fine. So in that way also we can tell, shortcut. But otherwise transition element should be the answer, and it is scandium. Atomic number 21 is nothing but related to scandium. Right? So the element is scandium, which is first element in the period number 4 related to transition metals. Related to transition metals. All of you have understood? So question number 2, option A should be the answer. All of you have understood? Okay. So shall we move to the next one? Or any doubts? Okay. So next, question number 3. In which of the following? In which of the following? In which of the following options? In which of the following options? The order. In which of the following options? The order of arrangement. The order of arrangement does not agree. Order of arrangement does not agree with variation, with the variation of property. Variation of property indicated against it. This is a neat question. This is related to neat question. So in which of the following options the order of arrangement does not agree with the variation of property indicated against it? Okay. Now the option A, iodine lesser than that of the bromine, lesser than that of the chlorine, lesser than that of the fluorine. So in the bracket we can write it as it is related to increasing electron gain enthalpy. Increasing in electron gain enthalpy. Next, option B, lithium less than sodium, less than potassium, less than rubidium. So this is increasing metallic radius. Metallic radius. Next, option C, aluminium ion plus 3 less than magnesium ion plus 2, sodium ion plus 1, and fluoride. So increasing ionic size. Increasing ionic size. Next, option D, boron less than carbon, less than nitrogen, less than oxygen. So this is increasing first ionization. Increasing first ionization enthalpy? This is the question. Increasing first ionization enthalpy. Can anyone? This is NEET phase 1, earlier one. They used to have this one exams. So this is related to NEET phase 1. So which of the following does not agree? It should be does not agree. Okay, so Achyuta, she has written, he or she, I don't know, sorry appa. So written that D should be the answer. Okay, so any other answer? Okay, Shri Vidya, she is telling A, and someone else also has written D only. Oh, Shri Vidya, A, Nagesh, D, then once again A, then D, okay, D and A, Mansi, okay, very good. It should be both. In this question, it is both A and D are the answers, no doubt. Very good, okay now? Now, because when it comes to first one, increasing in electron gain enthalpy, so that's where we have the wrong. As we have discussed, due to the small atomic size of the fluorine, since there will be electron-electron repulsion, chlorine should have come over there and fluorine should have come over on the other side. It should have been reversed, but it's wrong what they have given. So option A, yes, done. When it comes to option D, as we know, ionization enthalpy, they are talking about first ionization enthalpy. So that means removal of first electron. Okay? Yes, Ashish, but some questions they will be having two options like this earlier. This is NEET phase 1. Okay, na? So where two options are there, but if you write any one of these two, you should get the marks. Okay, any one of these two, you should get the marks. So here, first ionization enthalpy is there. So that means now don't worry. Now only one option you should tick. Yes, Ashish. Okay. But therefore either if you tick A or D, it should be right. No doubt. So when it comes to here, nitrogen half filled. If you see the electronic configuration, 2s2, 2p3, outer electronic configuration of nitrogen, half filled. So due to that, nitrogen would have gone to this side and oxygen should have come to other side. So therefore, option A and option D both are not correct. So any one of these two should tick. Naturally, only one option you should take, either A or D. If you take, you will get the marks. Okay? So that's where we have the answer for question number 3. Which are those? Either A or either B. And all of you have given either A and B, and some of you have given both. So that is very good. Very nice. Okay, na? So that's where we have the answer for question number 3. Okay? So we'll move to the next one. So this is once again related to medical exam. This one exam related only AIIMS. Earlier it used to be there. Now anyway, NEET exam will be there. Okay? So that is question number 4. Which is correct? Which is correct regarding, which is correct regarding size of atom? Which is correct regarding size of atom? Option A. Nitrogen less than oxygen. Option B. Boron less than neon. Option C. Vanadium greater than titanium. Option D. Sodium greater than potassium. So first one is nitrogen less than oxygen. Second one option is boron less than neon. Option C is vanadium greater than titanium. Then D, sodium greater than potassium. And which is correct, you should take. Any one of you? This is okay. It is actually less than. It looks like I have written 2. It is less than. Okay, A and D. A and D. Many of you are going with A and D. That means nitrogen is less than oxygen, which is correct. See the question properly. Which is correct regarding the size of the atom? Do you really agree? Nitrogen is smaller than oxygen? No. Oxygen is smaller compared to nitrogen. Right? Because oxygen comes after the nitrogen. So this is wrong. So they are asking about correct one. So vanadium and titanium. Right? So titanium should be greater than vanadium. So this is also wrong. So sodium greater than potassium. No, because potassium is down the sodium in the group. And down the group atomic size is going to increase. This is also wrong. Only correct answer is option B. Because as I told, neon, monoatomic in state, we are going to consider van der Waals radius. So therefore, neon will be of larger size because we are talking about van der Waals radius. Boron, it is a non-metal. We are going to consider covalent radius or atomic radius. So therefore, this is wrong. We cannot tell boron is less than neon because it is not comparable. They are not comparable. Fine. So therefore, option B should be the answer. Okay? Because they are asking which is correct. So therefore, in that case, neon, van der Waals radius since we are considering, so therefore it should be larger, no doubt. Okay? So due to that, option B should be the answer. All of you will agree? Okay? Any doubts? Anyway, so today I will stop here. All of you have understood what and all we have discussed. Okay? And whatever relation I have given, metallic property, non-metallic character, electronegativity, electropositivity and all. So you should write it on this in your notebook so that while going the exam, no need to read everything. You can just glance those whatever shortcuts I have given, equation form. Right? And don't write those equations in the exam. It's not required. You should explain because it will be asked for 2 to 3 marks. Okay? But for competitive exams, it will be help you out. Tomorrow, we are going to discuss some more questions. Okay? Any doubts in today's this one? Many people they have written no doubts. Fine. Okay? So fine. In that case, take care. Bye. Tomorrow, we are going to continue once again. Okay? Thank you.